working with this Python manager lately, and I wanted to share my enthusiasm for this tool. So I'm not a Pythonista, how they say, but when I had to use Python packages and Python written bioinformatics tools, I find this very useful. It's the modern way of using packages and Python projects. So what is UV is just a very fast command line tool for managing Python and package versions and Python environments in a very efficient way. It's written in Rust, which is a very efficient compile language. And in a way, it is like Conda, but only supporting Python environments and not the whole slew of system level libraries that Conda usually brings with it for their environment. So in fact, historically, Conda grew out of Python's own dependency hell, right? They needed to isolate various Python package versions and even Python versions, right, for various applications. But Conda also provided all the C and C++, compiled based system libraries that are needed for some complex setups. And UV, by contrast, only focuses on Python environments, and which is sidestepping Conda's heavyweight system library management. And it's a replacement for it's a drop-in replacement for most of the pip installation tools and other project managers like Poetry and virtual environments into, of course, that's the main strength. And for example, installation is very simple. It's the same principle as Conda. You don't need root privileges in order to manage your own local installation. So this can be done easily on the cluster, like an HPC environment, like JHPC. And indeed, it installs by default in .local/bin in your home directory. And then this should be in your path. And it's a quick installation, usually just fetching that URL that I've shown there. Now, the thing is, you don't even need to have Python installed theoretically to use UV, because it can install precompiled versions of Python. And a simple example here is how you create a project that, let's say, I want to create a project folder, a very basic project, not a proper Python project, but just having a simple script that requires specific libraries, packages, Python packages. So in this case, I wanted to test AWS Bedrock Access and to test some of their scripts, and I needed these specific packages, Boto3 and Python.m. And basically, the creation of a virtual environment in the directory involves running this uvvm command, and we can specify the version of Python that's desired. The system version in this example was usually it's behind is 3.9 or 10, depends on the Linux distribution, but UV can install whatever version it's available. So this is one of the most recent ones. And for this project, it's just shown how you can just start an environment, which is by default, if UV VM just creates a .vm subdirectory folder in the current directory, and you activate it, as they say here, with just a sourcing that activation script, and then just typing deactivate can take you out of the environment. And then once you are in the environment and it's activated, you can install whatever versions packages you want using the command uv pip install instead of just pip install. You can actually use pip install if the environment is activated, but only if you install also with uv pip install its own version of pip, a local version to that, because there sometimes could be conflicts between pip and setup tools and the very new Python version you have there. So it's using UV pip install in that environment is the safer way to install packages in this particular environment that was activated. Now let's assume that in this example, I have a script that's called testrock.py that has just testing a Bedrock access, for example, using these packages. And in order to run it, once the environment is activated, just running the script itself, it's easy. just in a simple invocation, especially if it's made executable, you can just directly type /testroc.py if that's a script. But if the environment is not activated, you can just go to that directory and use uv run, which is automatically it is going to look into the current directory or the parent directory for .vm folder, and it will activate that environment first and then run the script in that specific environment. Now, sometimes, after testing a script like that, if you want to have full reproducibility of what's happening there, and let's say we commit the script and an easy way to reproduce the environment, if you commit the script to Git, if you want to reproduce the same environment, you can use this pip freeze commands to write the requirements.txt file, which is used in many Python packages installations, right? You can just have a requirements.txt file that drives the dependencies, the packages that depend on that are needed for the specific Python environment or tool that you are trying to install. So in this case, requirements.txt, I'm saving the list of packages. Yeah, and also I'm here that I have this command that I suggested just to also show the Python version that is used, because by default, by using pip freeze, you don't see the Python version. So I added as the header for this requirements.txt file, I add the actual Python version that was used. Actually, I should have shown, yeah, I wanted to show live, but I'm not sure if it's right now working properly. So I basically this requirements.txt will have the instructions needed. If you clone the repository with your source code and this requirements.txt, you can reproduce the environment by installing this command. Actually, so what I'm writing in the first line of the requirements.txt file is this uvvm command that shows the Python environment, Python version that was requested. So this is what the first line here does. So this information is going to be in requirements.txt. And then also the second line, which is like commented in the requirements.txt, just shows how to use the requirements.txt itself, which has the packages using this command uv pip freeze. And that would be just a full information about how to reproduce the environment. Actually, let me see. I hope I can. Yeah, I was trying to here. So if I go to, I think I put here an example, and we can actually do it. So here, yeah, I don't have a .vm. So the idea would be to use this to create the actual environment. Yeah, right. So it's very fast because it's actually another way UV works. It caches all these previous commands in a directory, all the downloads that it had previously. So because I played with this version before, it actually cached this Python version, so it's very quickly available. And now, if I just install, it was about 3.env, right? I think. Right, even without activating the environment, actually UV-pip finds the environment. So the order here, I think, doesn't matter at this point. But now let's activate. So okay, so this is activate. And yeah, here if we look at the Python version, should be of course the one from our environment, because that's what reactivation does, among others. And now, well, yeah, that in order that if we do pip freeze, for example, well, I guess we'll see how the packages are written in that requirements.txt. Now, yeah, it would be information is going to be in the requirements.txt, so you can commit this file to GitHub, but the top commands are gonna the top two lines as shown here are actually going to have information about the Python version and how to create the environment and then how to actually use the requirements.txt itself. Now, the way I ran into this, it was as a very easy way to install bioinformatics tools. Since I'm not working all the time in Python, I still wanted to use some packages, like there are very, very complex and useful packages like ScanPy, for example, for single cell data processing. And these packages can be all installed very quickly with UV, these tools. But besides creating environments and managing, like the development and isolating environments, the UV tool actually is a command that directly downloads and installs existing tools usually from pip repository, PyPy repositories, right? So the way I show here the simple installation of a gget utility, which is a very versatile tool of getting in command line a lot of information about genes, and including query tissue expression data from various genomic databases. It's a lot to explore there. But the idea is that it's just as easy as running this command UV tool install, and what's this gonna do, and even specify the Python version that you want for this particular tool, which could be looked up in the installation instructions for the tool. And then this tool becomes available because it is actually installed with like a symbolic link in a .local in the home directory .local/bin directory there, like UV itself is there. So this is like a common repository for user installed tool. So people who used the pip install before, they know that location, this home directory .local/bin, is used if you install using the old way, which was using pip install in user mode, right? Which will install these packages and Python tools under this path .local, home.local. The problem here before was that if various programs and packages had different requirements, they cannot be installed all there. So UV solves this by having these tools actually as symbolic links in there, pointing to a full environment stored somewhere else under the .local path. So they run in separate environments. The way you install them, they're isolated. Now, another tool that was recent discovery for me was BioMCP, which is installed in a similar way. See, I can even provide a different version that installs all the dependencies using this. And this is a very interesting tool which allows querying of biomedical data sources like PubMed, clinicaltrials.gov, and myvariant.info. And since I've been looking for a while for a quick tool in command line to query specific DB SNP IDs in a terminal, and instead of having to start a browser, and of course you can use this in scripts and pipe retrieve variant information or even article searches. If you install it like that, which is very quick using UV tool, right, in your Linux environment, or Mac OS is the same, you can try a few searches there, like the examples I provided, which are impressive. Results are much faster actually than the gget tool that I showed earlier. I think they use a better query system. Now, UV and the use of Python tools becomes very relevant actually in this age of AI and LLM systems. And they are motivated, BioMCP actually MCP part comes from Model Context Protocol. And these tools are motivated by the recent efforts of providing context tools for large language models in order to improve the accuracy of the LLM responses by grounding them into specialized knowledge databases and updated information. So this MCP, which is the Model Context Protocol, is a specific standardized interface that is gaining popularity in the world of generative AI and LLMs recently. Now the old paradigm, just to explain what MCP is and how UV plays in it, of important role in it, is that large language models encode a large amount of knowledge in their weights, but they are distilled from pre-training on massive text corpora. But this embedded knowledge, it allows them to generate fluent and often useful and apparently reasonable responses. They are sometimes just the most plausible answers based on a given prompt, and they could be somewhat approximate. And their internal representation of the knowledge is inherently approximate and probabilistic, and also static, is frozen at the time of training. So LLMs can produce this kind of imprecise or outdated information and are prone to what we call confident hallucinations, especially in domains that require factual precision or up-to-date data. Now, the new paradigm, so the initial paradigm was the user prompt goes into LLM, and the LLM uses its weights and the knowledge distilled there in these weights and just generate a response, the most plausible response based on the user prompt and the weights. Now, this is direct, but could be imprecise and as I said, delusional sometimes. Sounds like I confidently say something that's wrong. Now, the new paradigm is it's LLM systems or agentic AI, which are basically LLMs given tools, external tools to retrieve more accurate information and more up-to-date. And they're important to know that these are deterministic tools as opposed to LLMs, which just use a lot of inherently not really deterministic. They can give different responses at different times for the same prompt. So these deterministic tools are given to LLMs for calling, for invoking, and they can be search engines or calculators or code interpreters or specialized database query tools. So these are added to the context as a response to the user prompt. The language model will invoke these tools to retrieve more accurate information and add it to the what's called the context of the inference. And then since the LM is very good at summarizing information, especially freshly given one, like the one coming from the tools, the final response has a much higher probability of being more accurate and integrating the information from the tools and from the weights with much higher accuracy. So this new race for providing better tools to increase the precision of LLMs led to the creation of this kind of tools that can be and protocols for providing this accurate context to LLMs. And this was a great push among many other benefits of AIs. I thought just having this information organized and made it queryable in a systematic way in order to build these tools for LLMs actually benefited us, I would say, it was lucky for us humans that we can also benefit from these AI tools. Because in the case of the MCP standard, the protocol that manages the interaction between the LLMs and these external tools is actually a very simple protocol that uses the basically standard output for providing text to LLMs to react to a query and it takes an input query and for a specific data and it returns text with the information for the LLM to process and summarize. And at the core of this, for all the Python MCP servers, that's how they are called, these external tools called MCP servers. At the core of this it's very popular now to use UVX, which is actually a shortcut for UV tool run. And the way UVX works when in invoking a specific tool like bioMCP that I showed earlier is by creating is installation free in the sense that it doesn't seem to install anything locally. It actually pulls from the package repositories, it pulls the package, so the package must be there, the tool to run must be there in the public repositories, unless you can also provide a local repository or some private repository, of course, for the tool. But the idea is that it pulls it on the fly, and the first time first invocation might take a little longer because it actually might download the packages and create this temporary ephemeral virtual environment. But the subsequent invocation of the tool with the same UVX command would use the cache. So this is one of the benefits of using this UV tool. It has a very strong caching approach to all the downloads. Like I said, Python versions and also packages. So it will just on the fly to pull the packages from the cache. So this is very fast, and apparently it was adopted by these MCP tools standards to work with LLM. And another, just to emphasize how efficient this system is, even though it seems to not install anything locally and is still very fast. There is an important thing to realize that when you add external tools to LLM, to AI systems, this introduces an extra latency, of course, because you have to query the external databases or invoke these tools and provide the response to LLM. So this there's additional time involved. So there is now a race to optimize this access. So the LLM systems are not, made much slower by inclusion of MCP server. So this is all of this. I like this because it also makes it useful for the rest of us, which are maybe not using these external tools for LM necessarily, but in our own workflows. And the good thing is that yes, we have this acceleration of standardization of access to this kind of databases, which we can benefit by invoking directly without having to use it in an LLM context, even though that was the initial impetus here. And also, as I mentioned, I think MCP, these tools or servers are using a very simple standard output input approach to communicate with LLMs. Then it's very easy to make a CLI version of these MCP servers. So which is what bioMCP did actually. They provide the bioMCP a core MCP server, and they just maybe as an afterthought, they also provided an easy CLI for the same exact query system, and it's quite fast and efficient. Now, another popular tool that I use with UV is Radian. I don't know how many of you used it before, but I found it as a very quick way, especially a quick way of getting into an interactive art session, especially in HPC environments like HPC. And it it's much easier to do this instead of trying to run either an RStudio, maybe in a remote fashion, or set up a maybe Visual Studio Code remote session. If I just want a quick interactive R session, I would just go and start Radian like with the command like this, and I get a prompt. It's like the R console, but again, very, very well, very easy to work with, in my opinion. Then now, let's see if I can just show it here, because earlier I tried to install it. And yeah, I was thinking and it's important in our context when you have an HPC environment, when you have a specific module that provides R and Python together, which is what our Conda R module here does. Now we see that there's for integration between Python and R, which happens with packages like Reticulate or other packages that are for interoperability between R and Python. We want to use the version of Python that can be integrated with the version of R that we have, right? And in this Conda R module, yeah, we have this both Python, and since a full Conda environment, have both Python and R. So there is a way to use, yeah, for this, okay. There is a way to use a specific version of Python actually when you create this UV environment. Actually, when you install this Radian as a tool. So I hope I can demonstrate here. So if it's to install, okay, yeah, copy this path here so I don't have to type it. Okay, I don't know what I did here. Sorry, I tried earlier and I don't know. I guess I copy to uninstall. Let me see if I can come uninstall. There's a problem right now on the transfer node that I think I am stuck with this. Because I had it earlier. Yeah, let's see maybe. Okay, so this was there. Now it was gonna work. Okay. I'm still not sure what didn't work here. Okay, I'm gonna try something easier maybe. I'm gonna try to go to another workstation where I have this, so I can just show you the Radian thing. So maybe a connectivity issue. I don't know what's happening. I'm not sure why I cannot connect right now. I was trying to use another Linux workstation to show this because there's something wrong with the transfer node right now. Mm. It's too.
I don't know if it helps, but I'm getting Radian to work pretty well in an HPC.
I'm on the wrong network or something. Oh, really? No, actually, I got it working, but I tried to uninstall it earlier, just to be able to show the installation how quickly it is. And somehow I have this stuck. There's some problem there with the files I noticed earlier just this morning.
Yeah, no, it's a nice interpreter. It does
Trying.
the auto completes and stuff.
Yeah, that was. So right now Radian is not there, of course, but if I try, so uninstall should not be. Yeah, that's device resource busy. I don't know where it's coming from. It's something new. Somehow the file is locked by other process, maybe, as I used it initially on the compute node, but it should be relieved. I don't have any running sessions, so I don't know what's happening here, and I cannot access other Linux servers apparently to show it right now from the laptop. Or maybe, yeah, and it cannot I guess I cannot even remove, because that's a problem, installation issue here. This directory cannot be removed right now properly, I think. Let's see if I can remove it like this. Yeah, that's something that I cannot do. I don't know where it's coming from. There's an NFS issue, locking issue that it's beyond my. I guess I'll have to ask the HPC admins for this. But about this issue, but I'm still surprised that I don't have access to other workstations here. Yeah, that's the worst time to have access problems with the Wi-Fi from the laptop. Yeah, okay, I guess we'll cut this out. I wanted to show what it actually shows. Yeah, how it works if it's not the... But yeah, basically, this is how the colors are weird here because I really want my prompt usually to not... Like the part of the prompt that shows like this dark blue, which is barely visible on the screen, is just a basic prompt that I don't really need to see to get in the way. So I like this color scheme actually. So once you are this is like a Radian environment, yes, you can easily see when you start typing, you can see this code completion that comes as you start typing some SUM, for example, it starts showing the summarized experiment as an obvious choice there. So we can, a lot of tab completion going on, of course, we are used to that in IDEs in general, in integrated development environments, right? And the same, what another thing that I found even better than what I experienced in RStudio is this auto completion that comes when you start accessing file paths, directory paths. So it actually shows when you start typing the directory name, it starts showing the file from that directory and stuff like that. So you can actually pick, instead of typing the full name, you can just pick, and it's too bad that I cannot show it live right now, but that would be the advantages. You can less typing and a lot of tab, but not tab like in code generation, because these are actually things that are either from memory, because from the R environment, objects from the R environment. That's another thing that I like about Radian. Apparently, the original R console has this introspection feature. It's of course it's aware of the object in the R environment, right? But also when you start typing like from a data frame, dollar and the name of, just type to see the columns, right? It will just show the list of the columns. I think that happens in the R Studio console too, if I'm not mistaken, or at least in R Studio environment. But to see this in a terminal, it's very helpful, right? So basically, it's a much quicker way to just go in, slice some data, subset data to export maybe in a text file, and then, or just to load some R data objects, right? So it's much easier for me than starting a full RStudio session or a VS Code with remote access. And not only that, but actually Radian can be set up as the default, as supported as a drop-in R console replacement within integrated development environments like VS Code. Cursor, Windsurf, and all these VS Studio, VS Code forks, including through SSH remote sessions. So from these IDs, it's just more convenient as a console there. For RStudio users, yeah, it probably doesn't make a huge difference. If you are already in RStudio, you already have these kind of features in there. But if you are just in a terminal or in a IDE console like the one in VS Code, you appreciate the convenience of a better shell session than the default R one, which doesn't have these auto completion features. Yeah, I think that's it. Basically, installing this UV should be very easy, but right now I have this file locking issue on that, on that which so I cannot show it, but that would be easy to have that Radian console installed and be there for whatever whenever you load conda R, which I know that the module conda R is loaded by many of us, right? If you don't want to also start RStudio there, you just, once you install this tool, Radian, you can just start Radian and work in the terminal directly quite quickly. I think that's it for it. If you have any questions about any of the things we talked about.
I'll text you. I had a question, maybe a couple. For UV, it looks like it's a combination of both package manager and like a project manager and a package manager, and then also Python like versions.
Yeah,
Yeah, you installs Python, but you don't use it to run Python, right?
Oh, no, when you define these environments here, where was that? This VM actually downloads UV VM, this command actually downloads unless it's already downloaded in cache, right? It downloads this version of Python, and it makes a symbolic link in .vm, right? For .vm bin for that Python version. So whatever you run here is going to use that part of Python version that you specified, which is in the cache. So your symbolic link is going from this virtual environment to the cache, which is in .local share, I think, somewhere. So they do use different version of Python and run them when you run the programs in that environment, right?
Okay, I see. Okay, so you just need to activate it like any other virtual environment, and then the Python's in the virtual environment.
Yeah, maybe actually, right. I can show this here. Oh, I just installed it there, right? So if we go to, what was it? Bedrock here, right? So here it VM bin. I requested 3.12, I think here too. So here you see Python, it actually links to this cache session, this cache directory here, right? That UV uses. It's like in .local share. This is the actual binary Python 3.12 is there. So it creates these symbolic links. So, and it's of course, when you activate the environment, yeah, it's like typical being, oh, sorry, actually, this is activate here, sorry.
And so no matter where you put it, it automatically puts it into your personal .local share.
Yeah, it makes a symlink in this environment. And when this environment is activated, of course, the path to that bin directory is first. So I think that's what the environment activation does, right? Let's see. So yeah, activation of the environment adds this in front of the path, right? So this, and it finds the Python from there. And of course, your script has to invoke, yeah, maybe that's what you're referring to.
Yeah, because it seems that it actually puts the real Python into.
No, you have to use this convention for this is what you meant. You have to always use, don't call directly slash user bin Python or something. You have to let the environment solve the location of the Python interpreter that you want to use, right?
I'm asking the question specifically because like I normally control the packages because we have size issues, as in not everybody can have their packages. So it's like interesting where it actually puts the location, like where everything is located, because that has like issues with who can actually use it. If it's like if I develop all of them with it, then it will be in my .local. So then like my staff can't use, will probably have like some type of issue using it just because they have no access to that. But there's probably a way to change that because there's a way of changing that with with Python as well. So
Oh, I see.
but yeah, no, it's a very niche issue.
No, same with Conda. It's very hard to make global installations, right? And I mean, with Conda, they
Yes.
solved it somehow, but UV, I think, is more for personal experiments like that.
Yeah, no, it's mad
The
hard to make
multi-user
it
is a
go.
challenge, yeah.
Yeah. But for the tools, because that's my other question, is it like a specific kinds of packages that are considered tools, or just any particular package that you can run as a tool?
So that was just examples out of many. I think even ScanPy scripts, there are some other scripts. Let me see. So besides I found two examples, gget and biomcp, right? But there are many others. Like there are some tools that you work with a lot of, I forgot how it's called, intervals, like genomic intervals, very fast querying of genomic intervals. So yeah, a lot of packages provide also executables, right, in .local/bin, but some of them are just packages for development. So they only install the packages, but so you are supposed to write the script that that uses those packages, right? But the tools are supposed to be only executables. So when you say UV tool, you usually aim for installing in .local/bin, installing the symbolic link to actual executable that you want to run, like gget, and bioMCP. And there were a few, I think I put a list there, but I didn't need a lot of them in the past. So Radian was one of the prominent ones for me, which is a good example of a package, a complex package with many dependencies, but which also provides a main executable. That's the whole purpose of that package, I guess. So ScanPy, I forgot. I know it's used mostly for the packages, but I think it also has some way to command line. Like TensorQTL, I think also has the main executable, right? There are other tools like they work like that. Packages plus tool, command line tool that you can use.
Thanks. It looks like Ron's got a question in the comments.
Yeah, let me see if I can. No. So yeah, okay. Let me see. Yeah, that was the thing. It's as opposed to Conda, indeed, which provides support for a lot of stuff, not just Python. The UV is dedicated to Python packages tooling because that was the main drive, even for Conda, as I mentioned, historically, the the dependency hell and the packages of various Python environments. That was a problem that was addressed initially by Conda, but Conda went one step farther. So this is what you're asking there, Ron, is about, yeah, using Conda instead, essentially.
Yeah, that's what I was asking because I don't see like how is this Python oriented like a tool like this UV would be any different from Conda because people are so used to Conda. I don't know if they will be able to switch to UV.
Oh, it's the main difference is speed, right? I mean, basically, it's very easy to even using UVX, like you don't even have to install. Conda installations are quite a big headache if you actually deal with them sometimes. Resolving environments takes a long time. It's
Mm,
if you try UV, it's just a matter of a couple of seconds to install tool.
right.
And UVX also does the same, and that's why it was adopted. UVX looks like it doesn't install anything, even though it does put stuff in cache. And this cannot be done with Conda right now. The way Conda works, it involves so many dependencies that it's a big problem.
Right. I have faced a lot of those issues with Conda. I agree with that.
And
I'll give
that's
it a
why
try with the UV.
Yeah, that's why AI, ML, the AI community right now, they made use of this speed exactly for this reason. They couldn't use Conda environments like that. It would be much harder. I mean, you can, but you have to install everything locally there.
Thanks, Jay.